While building a large-scale system, it is very important to do performance testing. Two most popular performance testing tools are Gatling and JMeter. In this video, we are going to learn how to do performance testing using Gatling. But before getting into Gatling, first let us understand why do we need to do performance testing in the first place. Usually, during the development, we work with the application as a single user and we may work with a small data set. Let's assume we are using a database and usually we have 100 records or at max 1000 records, and we work with the application as a single user at any given point of time. But in production, there will be huge volume of data and there can be a number of concurrent users. So when you are running your application, you may test your application and performance seems to be good enough. But once you deploy your application in production with so much volume of data and a number of concurrent users, the application may not perform as good as you want it to be. So it is very important to do this performance testing in a production-like environment. You should have an environment that is kind of very similar to your production in terms of hardware capacity and the number of users. You should kind of simulate to the real-time experience. So that way you are going to gauge your application performance in a realistic manner. In this video, we are going to learn how to write performance tests using Gatling for our DevZone application. In the previous video, I have already described what is DevZone application and how to write end-to-end tests using Playwright. To just quickly recap what a DevZone application looks like, here is our DevZone application, which is nothing but a bookmarking application where you have a number of bookmarks and you can navigate through bookmarks using this pagination, and you can search for bookmarks. Okay. And you can also navigate through bookmarks using these categories. Okay, and you can also log in as a user or as an admin, and if you are an admin or you created a bookmark, you will be able to see this edit and delete options. You can also create a new bookmark. Okay, so this is the whole functionality of the application, and we are going to write Gatling performance test for this application. Let us quickly explore Gatling documentation. Go to gatling.io and navigate to documentation, and here you can go to this installation page where we can see there are multiple ways of using Gatling. We can download Gatling as a bundle and then start it as a standalone Gatling tool, or if you are using any build tool like Maven, Gradle or SPT, you can use respective plugin to write and execute Gatling based tests. If you are completely new to Gatling, I highly recommend you to first go through these core concepts over here and then follow along this quick start guide. In this quick start guide, there is a sample reference application called computer database, and in this guide, if you follow along, we are going to perform various actions and then generate the simulations and finally execute them. So if you are new to Gatling, I highly recommend you to first go through these core concepts and then follow along this quick start guide before jumping onto our own application and then exploring how to write Gatling tests. For our DevZone application, we are going to write Gatling tests using Gradle build tool. So I have cloned the application into my IntelliJ IDEA, and here I have this module Gatling tests and I am using Gradle build tool. So I have added this Gatling plugin, and then I have added the test implementation dependency, which is nothing but Gatling HTTP Java. So this is all we need to get started writing Gatling performance tests. So once we have added this dependency, we need to follow some structure like typically in any Gradle project we will have src main Java, src test Java, something like that. But when we are using this Gatling plugin, we can add our Gatling related code in our src Gatling Java directory. Also, earlier Gatling only supports writing this performance test using Scala only, but in the recent versions, I think starting from 3.7, Gatling added support for writing simulations using Java and Kotlin as well. We are going to use Java. So here all the configuration files will be under src Gatling resources, and your simulations will go under src Gatling Java. But these are the default locations when you are using this Gradle Gatling plugin. But if you want to customize, there is a provision to it, and you can explore the Gatling Gradle plugin documentation to see how you can customize various things. So here we have some configuration files like Gatling config, Gatling aka config. So if you want to customize any of the default settings, you can, but in this video we are not going to customize any of those. And one important setting that you can use if you have this logback test.xml, which is going to configure logging for your Gatling test. So here by default, if you don't set any log level for this io.gatling.http engine response, it is not going to log all the detailed information about your HTTP request. But if you want to log only failing tests, you can enable debug level, and it is going to log whenever any test is failing. Or if you want to see all either passed or failed tests, you can set it to trace, so that you can see detailed information about what are the HTTP requests that are going in, and then what are the outputs, like what are the HTTP response and all the details that you want to see. You can set it to trace level, so that you will have more information. Suppose you are writing something but you are not getting expected output. If you want to see all the details, you can set it to trace. Okay. So having said that, let us first go through this post browsing simulation. So basically all our simulation classes should extend this simulation class, and then we are going to define what is the HTTP protocol we are going to follow in this particular simulation. So here we also need to specify what is the base URL for our application, and then we can specify some common headers. What are the accept header, what are the language header, things like that. You can set these common things here on the HTTP protocol level. Also, we may want to use some inputs while performing some of the activities. For example, we are defining various actions that are usually performed by our users of the DevZone application. For example, here we have a chain builder, which is nothing but a go to page. I just named it as go to page, which what we are trying to do, once we land on the home page, we want to navigate through page 1, 2, 3, 4, 5. So what I'm doing here, I'm using this repeat construct, where I'm saying we want to repeat this HTTP call for 5 times, and I'm going to hold each iteration value in n, and then while using this variable, I am going to set it as a session value with the name page number, and then we are going to execute this HTTP call, and I'm just giving a name to it, post page, and then it is going to be a get request, and this is the URL. And you can see we are using this expression hash braces and page number. So when we are executing this, it is going to be like page number 1, 2, 3, 4, 5, and as we mentioned, it is going to execute 5 times this HTTP request. And then we are adding this think time. So usually we are actually trying to simulate how user would use our application, so people don't just keep on clicking on different links or things like that, right? So first they go to some page and then think for some time and then perform some action. So we need to simulate that behavior using this pause, and here it is in seconds. So similarly here by category, so here what we are trying to do, we want to view posts based on the category. So for that the URL is, it's a get request and post slash category, and we need to pass some category. So what we can do, this is where feeders concept come in. So what we can do here, we have under resources data feeders, I have created this categories.csv file, and this is the header. We have only one parameter, category name, and we have Java, Spring Boot, and various other category names. So how I can use them? I have created this category feeder over here, and I have specified the location, and I specified I want to use a random category name. And while defining this chain builder, I start with taking that category feeder and then execute this HTTP request. Because my header name is category, I can reference these values using this category header name. So here like this. So what it will do, it is going to hit this HTTP endpoint by taking a random category name from that file and include it here, and then trigger the HTTP request. So similarly, I have search chain builder also. So again, we are simulating user search behavior. So there is a search keywords, a bunch of search keywords, and header name is query. So how we are simulating that? We are saying we are going to execute a HTTP request with get request, and then this is the endpoint, and this query is nothing but the header in that search.csv file. And finally, we are aggregating all these actions into browse post chain builder and chaining them one after another. And we create a scene builder by giving a name to it and then executing all these various individual HTTP requests. Finally, we are going to set up how many users are there using this inject open ramp users 100 during 10. What does this mean? So usually in a realistic manner, people don't start all at once, right? People may gradually join and then start using your application. So here what we are saying is, we are trying to simulate as if 100 users are using our application, but we are going to ramp up all those users in 10 seconds, not all at once. Okay, that is what we are setting up here. And then we are giving the HTTP protocol which we defined here, and we are making assertions because we are writing tests here. Obviously we need to assert something, right? So our assertions is, for all these HTTP requests that we are firing, the max response time should be less than 800 milliseconds, and then successful rate percentage is 100. So that means all the tests should pass. But in a realistic manner, sometimes you might not have all the requests serving below 800 milliseconds, or when you are increasing number of users, there could be due to latency or some other reasons, it could some of the requests could fail, whereas with a lower number of users it could pass. So usually it is like a 98 percentile or something like that, but just for the sake of running this demo, I am setting it to 100. Okay, so this is how we created a simulation where we are browsing various ways, like we are navigating through different pagination, and then we are browsing through various categories, and then we are performing various search operations. Finally, we are combining all of them, and then with 100 users ramping up over 10 seconds, we are performing all these tests, finally asserting this. In the similar manner, we have another simulation called post creation simulation. So here, for creating a new post, we should be first logging in, and then we should be able to perform that, right? So it is, again, we define this HTTP protocol just like in the same manner, and then we have a couple of post feeders and credentials feeders. So here we need to log in, right? We have a couple of users credential here, and the header contains username and password. So when we want to refer a username, we can refer this, and when we want to refer the password value, we can refer with this header value. And similarly, we have URL title category as a CSV, where we have the URL of the bookmark and what is the title we want to give for that and what are the category for each of them. So we have this post CSV file also. So once we define all of them, first we are creating this login chain builder where we are taking the credentials from that credentials CSV file, and then we are first navigating to the login page, and then because we are using Spring Boot and Thymeleaf, and we are enabled this Spring Security cross-site request forgery, we are setting up some we are storing this CSRF token value that is automatically included in the form in this CSRF variable, and then we are going to submit this login request to HTTP post using HTTP post method to this login URL, and also we are sending CSRF token that we captured, and then we are including this username and password with these values. These values are coming from this credentials.csv file. Okay, and then we are creating a new post. Here again we are taking the feeder from post feeder, and then first we are navigating to the post new page and again taking this CSRF token value. So basically when you are using Spring Boot with Thymeleaf, and whenever you are going to do any post operation, and if you didn't turn off this CSRF validation, you need to include the CSRF token. So we are capturing what is the CSRF token in the current form, and then while submitting the form we are including that value again. Okay, so it is again a simple form submission. Here we include these all form parameters and then submit this, and we are composing the create flow by logging and then pause time including think time for 2 seconds and then submitting this, and similarly we are ramping our 100 users over 10 seconds and asserting the response times. Okay, so this is how we can create these Gatling simulations, and then because we have added Gatling plugin for our build.gradle file, we get a Gatling run target or command that we can execute to run our simulations. So let us go to our project. So right now I am inside the Gatling tests directory, and here I can run Gradle Gatling run. So this is the task that I can run that will execute all our performance tests. So here I just run this Gradle Gatling run, and it is going to first it is running post creation simulations here, and here we can see it is getting executed. So here you can see if all of your requests are succeeding, you can see all time in seconds here under OK, and if any of the HTTP requests fail, you can see under KO. Okay, so here it is executing all that is, and here now it is executing this post browsing simulation, and we can see it is navigating to different pages here, page 1 2 3 4 5. Okay, and then it is navigating posts by category and search and various ways. So finally it is going to generate a report like this. So how many requests that took less than 800 seconds. So in our case all of them took less than 800 seconds. That's why our tests are successful, otherwise it's gonna fail. Okay, so we can also see the generated simulations over here. We can see all of our requests received response below 800 milliseconds, and you can see various details about each of the HTTP requests that we filed. Okay, and there is a simulation for post creation as well. So if you go to post creation simulation, it is another report that is generated for that different simulation. So we can see all this graphical representation as well. If you are new to Gatling and you want to understand what does this report means and which represents what, so I highly recommend you to read this blog post which goes in detail explain what is that report and what each part represents what information. So this article is explaining every detail that you want to know about this particular Gatling report. Okay, so I'll share this link in the video description. I hope this video is helpful to get started with Gatling, but I highly recommend you to go through this Gatling documentation and then explore more on how effectively you can use Gatling for various other scenarios as well. Thanks for watching. Bye bye.